Today we're going to have a recap on series and parallel circuits. So let's start off with a series circuit. So you have your battery, you have your resistors, 1, 2, 3, and then you have a voltmeter. So the resistors are all in series with each other. They're not on a separate line like they are in parallel. And there are some rules that go with series circuits. The first one is that the current is the same throughout each load. By load, I mean something that takes the electrical energy. So in this case, the resistance. So the resistor here, here, and here all feel the same current going through them. However, number 2, the voltage is shared. So if your total voltage is 9 volts and the resistance for these are all the same, then your voltage is going to be spread evenly too. So you'd get 3 volts here, 3 volts there, 3 volts there. But 3 plus 3 plus 3 equals 9, so that makes sense because the sum of all of these equals the total voltage. So therefore, again, voltage is shared between the load. And then number 3, resistance. The total resistance is equal to R1 plus R2. That goes back to the idea that if the resistance in each one is the same, so let's say that it's 3 ohms, 3 ohms, 3 ohms, and you have 9 volts, you're going to have a total current of 1, using this equation, 9 volts total, 9 ohms total, 3, 3, 3, and to find out what I is, 9 divided by 9, divide both sides by 9, you should get that the current is equal to 1 amp. Hopefully that makes sense. I'm going to have an example to sort of tie this all together. So find the resistance. Okay, so using rule number 3, the total resistance is going to equal R1 plus R2. So if we have a 20 ohm resistor in series with a 30 and a 50 ohm, we're going to add them together. So 20 plus 30 is 50, 50 plus 50 is 100. So your total resistance through your circuit is going to be 100 ohms. Now, to calculate the total current, what you're going to end up doing is, remember, the key word here is total. So your total potential difference is 125 and your total resistance is 100. So 125 divided by 100 should give you 1.25 amps. I'm going to check that because I might be being a bit silly. Yep, 1.25 amps. Okay, so the current through A, B, and C. Okay, so using rule number 1, the current is the same throughout the whole thing. So therefore, between the current through A is 1.25 amps, the current through B is 1.25 amps, the current through C is also 1.25 amps. Hopefully that makes sense. And then let's move on to IV. What is the potential difference across A? So we know that the total potential difference is 125, but that doesn't mean we know what the potential difference is across A, because voltage is shared in a series circuit. So we know that the current is the same in a series circuit, which is equal to 1.25 amps. So 1.25 is your I value, and your resistor value is 20. So using this equation to find out what V is, 1.25 times R should give us, let me use the calculator again, 1.25 times by 20, you should get a volt reading of 25 volts across A. And if we were to calculate B and C, you do the exact same thing. Okay, hopefully that makes sense. Now let's move on to a parallel circuit. So this is what a parallel circuit usually looks like. You have your battery, you have some bulbs, 2 bulbs are in series, and then that's in parallel with another bulb. So in a parallel circuit, you have 3 rules, just like in a series circuit, where number 1, instead of the current being the same, in this case the voltage is the same. So the volt across this bulb and this bulb and this bulb are all the same. Well, actually the voltage is shared between these 2, but this system and this system, the voltage is the same. Okay, so number 2, the total current is the sum of all the individual currents. So just like here where the current is the same and the voltage is shared, it's sort of the opposite thing, because current is the sum of all the individual currents. So current is indeed now shared in a parallel circuit. So the current across here and here is the same, but the current between this system and this system, because they're in parallel, will be shared. So if you have 6 volts coming in, let's say 4 volts goes to this, not 4 volts, sorry, you have 6 amps coming in, 4 goes here and 2 goes there, or 4 goes here and 2 goes there. It just depends. Now, number 3 is that the total resistance of the 2 resistors or lamps or whatever you have, but in this case, when you have resistors, the total resistance of 2 resistors in parallel is less than having one single resistor in series. So basically, for a parallel circuit, you're going to have a lower resistance than if you were to have resistors in a series circuit. Hopefully that makes sense. Alright, so I'm going to have a question here that I'd like you all to try. You have, similar to here, you have your 125 volts, but in this case you have 20 ohms in parallel with 100 ohms and 50 ohms. I want you to pause the video and try and answer I and II. Okay, hopefully you've calculated, hopefully you've unpaused the video and calculated your answers. So, I, the voltage across each resistor. Using rule number 1, the voltage is going to be the same through each resistor. So therefore, you're just going to have 125 volts through 20, you're going to have 125 volts through 100, you're going to have 125 volts through 50. The voltage in a parallel system is the same. And II, current in the 100 ohm resistor. Okay, so note that current is the sum of all the individual currents. So you can calculate the current by using Ohm's law. You know that the voltage is 125 and you know that the resistance is 100. So you would do 125 divided by 100, which gives you 1.25. And that is 1.25 is the current across a parallel circuit for the 100 ohm resistor. Hopefully that should all make sense. If not, let me know. And thank you for taking the time out of your day to watch my video. Bye!